Okay, once we have the body created and the features added to it, what we're going to do is move into more of an assembly design portion of the demonstration using the number 2-assemblydesign.asm file. One of the first things that I want to point out is in ST3 we've made some nice changes to configurations. For example, if I come down, I can pick body only, and I can click OK, and it shows me just the body. And you can see we've already added some other features to this particular body to complete its design. But as a user, I also might want to look at more than one configuration at a time. So now I can grab the assembly, in this case the handle, and the mixer bottom, and by checking them both, it's going to turn both of those on. So a slight change, but a nice change for our users that want to maybe combine configurations. Now for this particular demonstration, we're going to look at just the mixer bottom by itself. So I'll turn off the other handle assembly. Then I'm going to come over to my parts library, and I'm going to grab the motor assembly and drag it into my document. And as it comes in, the assembly automatically puts me in a place part mode where it's going to allow me to add assembly relationships. In other words, I want to create a mate relationship between the bottom face and the top of this boss. And then I can go ahead and do an alignment between the holes or the outside radius and the boss, and it locks that particular motor into position where it needs to be. Now for the rest of this particular portion of the demonstration, we're going to focus in on modeling the back frame that supports the back side of this motor, and we're going to use synchronous modeling techniques to do that. So in order to do that, we'll go ahead into the motor assembly, and we're going to edit into the motor assembly. Once we're into that assembly, you'll notice that Solid Edge ST3 tells us we're there. It highlights everything in yellow, meaning we've in place activated. I am then going to identify the back frame, and I'm going to edit it. And it's a part that I've already started, and I can turn on the background components of the assembly because we're going to utilize some of those components to help us build this design. Now you can see I've already got a sketch created kind of in the rough place where I want it to be. And before I continue with that, I'm going to go ahead and add a couple of dimensions to it. And as I do this, let me go ahead and turn the background components back off just for this section as we add these dimensions, and give you a better idea of what I'm doing as far as dimensions that I'm placing. And I'm going to unlock that last one. Now obviously I can make a change to this model, and you can see that it updates up top there. But what I really would like in this model is for all three sides to be the same. So if I come over to this particular dimension and do a right mouse button click, I can edit its formula and basically set it equal to this particular dimension and check it off. Now once I do that, you can see that it does set that dimension value equal to that dimension value. Let's go ahead and create our model. Before we continue with that, I'm going to come down. Now you'll notice that as we turn our parts back on, you'll notice that I can dynamically place this, or drag the identify the region and then drag the model down, or I can key in a precision value. In this case I want it to be 18 millimeters, so I'm just going to key that value in. Our dimensions are notice stay with the design, and that's what we're looking for. Now if I come over to this 6 millimeter, obviously I can change its value, and you can see it update, but that's really not what we're looking for. I really want it to be a part of the rest of the same thickness as this, so I'm going to set it to 5 millimeters. Then what happens is when I identify the 5 millimeters to make a change to its size, you'll notice that live rules automatically pick up and are going to monitor this model. So if I decide to start changing the size of the model, you'll notice how all the sides change at the same time. Live rules has picked up a symmetry, so the symmetry, and it's also going to maintain this dimension that I set equal to the 625. So now that we have our wall thickness where we want it, the last dimension change, I'm going to set this to 32 millimeters. Okay, so now we can start kind of looking at our design itself. And what I'm going to do is go ahead and add some rounds. And I'm going to use a 3 millimeter radius on the outside and inside rounds of our model. Once that's done, I'm going to turn off those dimensions. And then what we want to do is we want to build the area that's going to encompass this bearing and shaft. In order to do that, we can identify this back face that is the face that we want to draw on, and if we want to align that face, what we call sketch view, you can see we can kind of look at it from a sketch point of view. And I'm going to pick up center and just basically come out around 20 millimeters. Now once that's been created, again we can pick up the region and use our plus minus option to pick all three of these regions and pull that out, and we're going to come out about 5 millimeters. I'm going to create another circle and work off of this back face of the new circle we just created, and you notice as I touch its edge it'll show the center point, and then I can lock into center and I can come out about 9 millimeters. And then finally, to finish this portion, we can pull this out again about 5 millimeters. So now we've got kind of the rough design of what's going to house this, these internal components. I'm going to go ahead and go back to my rounding. I'm going to change that back to 2 millimeters and pick up those 3 sharp edges because we don't want any sharp edges on our model. And very quickly we can kind of get in a roughed model here. Now I'm going to go ahead and turn off the background components and continue with my design. What I want to do next is to identify the back face of this boss, because I want to extend it over. Using my space bar, I can go into the plus minus selection and just select those 2 faces. Now you'll notice as I use space bar, it'll take me into the plus mode, then the minus mode, so I can actually remove faces from my selection, or the plus minus mode. So it's very easy to do to use that particular tool. And then I'm going to change my option once the steering wheel is available. Change my option to extrude and basically pull these 2 faces out. I'm going to come out about 6 millimeters. Once that's done, I can then come down and grab this face, and in this time I'm going to actually turn off the symmetry and planar, and I just want to pull this face up to the end point of that face to create the model that I'm looking for. Now, obviously I need to make room for those internal components, and the best way to do that is to use our thin wall command. Now some people refer to it as shelling, but we call it thin wall. It automatically gives us a default wall thickness, and 1 millimeter is fine. So I'm going to identify the open face, and you'll notice it automatically gives me dynamic, or it gives me a preview of what that thin wall is going to look like. Unfortunately, it's also thin walled these side walls, and I don't want to include them in the thin wall. So what I'm going to do is go to a top view, and I'm going to pick the add or exclude faces, and we'll basically exclude the faces that I'm going to fence select here. And now you'll notice that those faces are excluded. If I right mouse button click, it thin walls the model out, and it excluded these side faces. Exactly what I was looking for. So we're moving right along fairly quick. What I would like to do now is go ahead and create just a couple of lines that are going to depict where we cut away some material for a clearance for these internal components. So I'm just going to pull that down, and I'm going to also add a line on the back side here. And again, dimension, I can add dimensions and do this with precision if I'd like, but just for the sake of getting them done, I'm going to go ahead and identify this region and pull it through, and you notice it automatically knows to remove the material. And then on this particular region, you'll notice I can either remove material, but if I pull it out, it's going to add material automatically. So synchronous design picks up your intent and does a really good job. You'll notice that it does go ahead and adds that material for us. Now you can kind of see where I'm going. I've got good clearance for my internal components. And now what I want to do is I want to build a wall that comes out around this model. In order to do that, I'm going to use this part of the design with the inner part copy command.